number 4, question number 8. Very similar to number 7, we're still going to have our distribution. We are still asking questions about whether or not the population mean is, or the relationship between the population mean and a certain value, 211. In this case, though, I needed you to do the opposite of whatever test you ran before. So if in question 7 you did the correct thing and you ran a two-tailed hypothesis test, then in question number 8 you need to run a one-tailed hypothesis test. I did not care what direction your tail was. I didn't want to give away that the question number 7 should be two-tailed, so it was your choice for question number 8. I will demonstrate a one-tailed test to the right because it seemed like an okay thing to do, but it doesn't matter which way you do it. And almost all of the steps are the same if you did a right-tailed test versus a left-tailed test. The only thing that will ultimately change is your p-value. So again, here we have our distribution. This is still the distribution of sample means, and we have our population mean down the middle. The first thing that we need to do is come up with our null hypothesis. And this was your choice. So in my case, I was interested in a right-sided test, a right-tailed test. That means, or you can think about it, if I were trying to publish a paper or make it into the news, wanted my results to make it in the news, to be important, it will only be important if my result is big, so kind of a high positive number. That means I do not get, so this is what I want to have happen. It means I do not get published. My results are boring if I have a smaller number. That not get published, that boring number, that is our null hypothesis. So my null hypothesis will be less than or equal to my mu of 211. And the thing I care about, the thing that will be interesting, the thing that gets me published, the thing that I will reject the null hypothesis for is going this way. So that is the way to think about it. There's the side you care about, the side that gets you published. That is the side that you will reject your null hypothesis from. And the other side is your null hypothesis. So I was interested in a right-hand test arbitrarily. Right hand is a greater than my mean, a big number, so my null hypothesis will be less than and equal to 211. Does that equal to matter? Yes and no. Formally, yes. The combination of the null hypothesis and the alternative to the null hypothesis has to cover all possible options. So there can't be values that are not included in at least one of those. So this is my null. I'll do null. So my alternative to the null hypothesis then is going to be greater than 211. So we're kind of talking about whether or not that equal sign matters. So all values have to be covered by one or well, at least one of these. In this case, they are. So there's 211. So I'm including everything to the left. I'm including 211 itself. And the alternative is everything above. That is every possible number now. If I had a null hypothesis that was less than 211, and an alternative that was greater than 211, 11, then I have the left-hand side of the curve, I have the right-hand side of the curve, but I don't have 211 itself. And that's not allowed. We have to, again, be able to consider every number. That's kind of what the theory says. In practice, does it matter? No, it does not. It doesn't affect our numbers in any way because, if you remember, the normal distribution and the t-distribution are continuous. It's every possible number is in here. So 211 is here, 211.01, 0.001, 0.0001. All of those numbers are in there to an arbitrary precision, any number of decimal points that you want. And so the probability of getting any specific number, such as 211.000, etc., the probability of getting that specific number is 0. There's a 0 chance of getting a particular specific number. And because that probability is 0, it doesn't affect any of our calculations. So do you need to include the equal sign? Yes, to be formal about it. But should you forget it, it won't mess up your numbers. Okay, so there's that. Let's get into how we actually solve this. Let's actually stop this now, just so we don't mess up, and we'll create another video for that.